This is an atomic absorption spectrometer. So what happens here is we have a lamp. Say we're going to do lead. There's lead. I need to turn that on. So what happens in atomic absorption spectroscopy is we have a lamp. This is a copper lamp.
These guys want to put their hands because
Okay.
him.
I'm going to demonstrate first.
First, and then let him run the samples and processing the results, printing everything.
Is it okay for me to do a video, by the way?
Sure.
Yeah.
Okay, thank you.
So we have a lamp, and there's actually copper in there. You can see the copper color. So if you excite that copper, it will be emitting photons at the energies at which photons of copper, when they move in their shells, the electrons jump from shell to shell or from orbital to orbital. It will emit photons at specific wavelengths of light based on that element. So those wavelengths will be transmitted through mirrors into the system, into a spectrometer, which will separate that light out. And we have a prism and a grating that both move in conjunction to let just that wavelength of light out and go through the flame. So you have atomic copper here emitting wavelengths of copper wavelengths, or lead, or whatever element you're using, so that if you're using a copper lamp, any copper in the flame will absorb those specific photons at those specific energies. So the photons, it's really quantum mechanics. So you have it has to be that exact energy for it to be absorbed here. So the exact energy of the photons leaving this copper will be the exact energy absorbed by copper in the flame. So the photons will be absorbed in the flame. So you can look at the absorbance of how many copper atoms are in the flame using Beer's law. This is an absorption cell, to find out, to give us an absorbance and a concentration. So that's kind of the gist of how it works. Physically, we have the lamps, we have this nebulizer, so we have gas coming into the nebulizer and the sample, liquid sample, and they come together and make a mist, a spray. And that spray gets mixed in the chamber, comes out through the flame, and that's where you have the light coming through, will interact. So if we go to lamp setup, we're going to do lead, so we can turn lead on. Might as well turn copper on. And we need to open a method, so we go to analysis, open, and we're going to pick a lead method. And then if we go to continuous graphics, so right now, if you can hear it, the motors are moving. Excuse me. The motors are moving the grating in the prism to get that specific wavelength of light, and we're going to look at. I'll have to see which wavelength it's going to, but it'll be a lead wavelength, and we'll be able to see the light filming through here, maybe. Much better with copper. I can't see it.